Today we're going to cover the calibration of our SD1 explosion-proof detector head. And this head is set up presently for hydrogen gas, H2. You can see the CH4 methane label on here, but it can have sensors that can actually be calibrated to either hydrogen or methane, and we have other sensors for other gases as well. So as we can see, this detector here is has a red label on it, basically around the perimeter of the display. And that signifies that it's an LEL range, or lower explosive limit range detector. We also have a ppm level detector, which uses a different type of sensor. This is a catalytic type sensor in here presently, and the ppm range would use a MOS or metal oxide semiconductor type sensor. And then the label here would be yellow instead of red. So right away you can tell what kind of a range of detector you have just by the color of the label. Red would be LEL and yellow would be ppm. So if you're going to be detecting benzene in a ppm range, then your detector head would have a yellow label. Okay, but otherwise the sensor assembly would look pretty much the same. The sensor itself is a plug-in type of sensor, and then the sensor guard here just threads into the assembly here and cinches that sensor tight, so it's nice and snug. Then you have a little set screw here that you can tighten up the guard so that no one can take the guard off from around the flame arrestor. All right, let's take a look at the detector head in general. I want to point out that you've got some label information on this side. So it gives you the model number, gives you the instrument number or serial number, and also the date of manufacturer, and then the gas that it was originally set up to. In this case, there is a CH4 there. Okay. And then the sensor model number is also there. So I've already pre-loosened up these screws here, and then I'm just going to open this up to show you the inside. Basically, it's just a simple PCB board in the back. You've got a relay here, and then your terminal connector here. So you've got the sensor wiring going from right here, this harness, to that connector, and then from the connector down out of the hub, and then up to a controller that you might be connected to. In this case, we have it connected to our Beacon 410A 4-channel controller. Okay, so next we're going to cover a calibration procedure for this. And even though I'm using the LEL range for hydrogen, as I mentioned, I'll make some comments regarding benzene calibrations. So basically, the items that we have here are a calibration cylinder. This one is 50% LEL, hydrogen in a balance of air. 2% by volume would be equal to 50% LEL for hydrogen. I've got a fixed flow regulator at the top. We've got a pressure gauge and knob, and this regulator is flowing at 0.5 liters per minute. So that's what we want here. It's a 103 liter cylinder of gas. I've got just a simple little length of calibration tubing. Typically, ours is 3 feet long. This one's a little bit shorter. It's probably about maybe 1.5 feet or almost 2 feet. And this is a calibration cup. This is a proprietary cup that is designed for use with the SD1 series. So it's got an O-ring to give you a good seal. You've got the gas out port, and then also a gas in port. So it quickly identifies how to connect your hose and where you should connect it. All right, and then we also have a magnet. So this is a magnet that we can use for non-intrusive calibration. Since the detector head is explosion proof, once you have these screws tightened down, then you can use the magnet to touch these little pads that are on each side of the housing to access different modes. All right, so we'll do that right now. I've already got the regulator on the cylinder. So I'm going to take my magnet and I'm going to hold it up to this top pad here. Okay, and then that brings up a setup mode, so to speak, or a confirmation mode of 1-0. And then your pilot light is now blinking, so that shows you you're not in a gas detection mode any longer. So you're in a basically a maintenance mode, so to speak. All right, so now I can use either of these other two pads on the other side The top button would be to take values upward, and this bottom pad would be to take values downward. So basically I want to get to 1-3. So I'll just use my magnet and just touch this top pad, and it's pretty sensitive, and I'm at 1-3. All right. Once I'm at 1-3, I can actually go into the calibration portion of the maintenance mode. And the way I do that is I go to the bottom pad on the left side, hold it down, or touch it, I should say. And I want to have dashes appear. And then once those dashes appear, I want to touch the pad again and hold my magnet until I get to 2-0. I'll just take a second or two. Okay, there we go, 2-0. And now to do an air adjustment, so zeroing the sensor to ambient air conditions, you want to make sure you're in a gas-free atmosphere, as we are right now in this office. And I'm going to take the display to 2-1. So raise that value up there to 2-1. And now I will touch the pad, the set pad over here on the lower left. Okay, and now it shows 0, or actually minus 0.0, and that's fine. And it might be a value that's elevated, a little bit low, or a little bit negative. That doesn't really matter too much. And then at this point, what I want to do is touch the pad again. And then you want the word to say cal, and then it'll say pass. Okay, so there we passed our air adjustment to the gas-free atmosphere. And now I want to put some span gas to it. So now I want to take the up value pad to 2-2, and that is the calibration level. So once again, I'm going to go over to the set pad. Just hold my magnet there for a moment. Okay, and I'm at 0 basically. So at this point, I can put the cal gas to it, which is what we're going to do. So if you're detecting benzene, instead of having 50% LAL hydrogen like I have right now, you might have 500 ppm of benzene, or 100 ppm or 200 ppm, whatever the value is, it'll be below the full scale of the sensor. And the other thing that you would be using in the process of calibrating for benzene in a ppm range is you would have a humidifier tube. And a humidifier tube is something that looks a little bit like this tube, but it's actually got a section of the tubing is porous. It looks like a little bit braided type of texture, and it's porous and actually allows humidity to come in from the ambient air into the sample tube itself. And then there will be little fittings on each end where you can actually fit one fitting into calibration tubing, and then the other fitting could go onto the regulator. So, or rather the cal cup, I should say. The one end into the cal cup, one end to the regulator. So you'll have little tube sections that'll allow you to do that. So basically, I'm going to connect my calibration tubing right now onto this hose barb regulator. And if this were benzene, then I would connect my section of that permeable tube, or the humidifier tube, and I would put one end here and then the other end on this cal cup. So then I want my gas sample going through the membrane then just before entering into the unit. Okay, so that's how basically you would do a ppm range for hydrocarbons, or in benzene if that's what you're interested in detecting primarily. But since I'm in the LAL range for this particular detector head, I don't need a humidifier. The reason you need a humidifier is that you have dry gas in the cylinder, there's no moisture, and when you're in a high LAL range, the dryness of the gas doesn't make any difference in the response to the sensor from an ambient air leak versus a cylinder. But when you get down into really low ppm levels and you have a very sensitive sensor, then there will be differences between a detection that the sensor picks up from ambient air, which has humidity, versus what the sensor will detect and read out picking up dry air from a cylinder. So we want to humidify that sample when we're working with a very sensitive ppm range sensor. Okay, so just a little bit of discussion about that. So now I'm going to get my cal cup on here, and I just want to push that on, get a reasonable seat, a nice tight, there, that's good enough. And then put my other end of the tubing on the nipple, the gas end nipple. Okay, and now I'm going to open up the valve to the regulator and flow that gas at half a liter per minute. Okay, now we can see that it's pretty sensitive, so it's rising rapidly. And I did calibrate it yesterday to about 50% LEL, so it's going to be pretty close. All right, so we'll see if it goes any higher. Give it some time here. Okay, so you can see it's right on the money from yesterday. So let's say the value only went up to 40. All right, and then it's stabilized, just like you see it. So it's going to say 40. What we would do then is we would hit the set pad again once the read is stabilized. And what I want to do is I want to get that reading to flash. Okay, now it's flashing. Okay, so what you want to do is you want the instrument to acknowledge where it's stabilized at, and then you'll use the up and down pads to change the value to what it really should be. All right, so if I had been down at 40, then I would have, once it's flashing, then you can go up or down to get it to 50, which is what I'm calibrating with, 50% LEL hydrogen. So I'll take it to 50. Okay, a little bit too far there. All right, there's 50. And then once I'm at 50, go back to the set pad and pass. So I'll turn my gas off. I'm back to, I close up the regulator valve. I'm back to 2-2. Now I want to advance to 2-7, which is the point where I can go back to the main menu easily. Okay, so once I'm at 2-7, then I just hold down the top pad over here on the left, which is the mode pad. Just hold the key there, and it's back down to the normal operation mode. So you can see the gas is coming back down slowly, the reading I should say. And if I pull the cal cup off, then we're obviously going to decrease a lot faster. And now the reading is dropping rapidly back down towards 0. So pretty close there. Now we're at 2. Now we're at 0. All right. So we're back in normal operation mode, and gas has been disconnected. Regulator's been turned off. And basically, that's how you calibrate the SD1. Very simple, actually, as you can see.